Hello, in this video we're going to talk about another force that has been determined experimentally, and that's the drag force, better known as air resistance. So the force of drag is equal to, and this is just an experimental result, 1/2 times a coefficient c times the density of air times the cross-sectional area of the object times the velocity of the object squared. Oh, a lot of stuff in there. Don't worry, I'll write down each of these just so we have it. So the 1/2 is just a convention because, let's actually do this from the reverse, because c is just a constant, and we could have easily put the 1/2 in the c, so that's just an arbitrary choice. A here is the cross-sectional area of the object. So for example, if you had a sphere, the cross-section of a sphere as it flies through the air is a circle. So the cross-sectional area of that sphere would be pi r squared instead of the total area of a sphere. Rho here is the density of the material the object's moving through. For our purposes, that's basically going to be air. And the density of air is pretty close to 1.2 kilograms per cubic meter. Just for reference. If it was moving through water, you'd want to use the density of water. Okay, and then c is called the drag coefficient. And like other coefficients that we've seen so far, it's unitless. Coefficients don't have to be unitless, but frequently they are. So this is roughly accounting for how the object interacts with the air, and that's not a simple thing. It can actually be very complicated how objects interact with air, because you'll get turbulence and eddy currents and all kinds of fancy stuff that we don't really want to get into. So let's look at some typical values for the drag coefficient. Okay, if the object is blunt, like a brick, something just flat in front, in that case the drag coefficient is pretty close to 1, and that's about the worst drag coefficient you can have. A streamlined object has a drag coefficient that's less than 0.1, like an airplane would be less, significantly less in some cases than 0.1. And if you're kind of in the middle, like a sphere, and you can approximate many objects as more or less round, then the drag coefficient is about half. Okay, so just to give you a rough idea of what kinds of numbers you plug in here. So mostly what's determining the drag is the velocity, because velocity is squared. This is for moderate speeds. If the object is moving really fast, like approaching the speed of sound or greater than the speed of sound, then you have a different form for the drag equation. It depends on a different power of v, you have a different drag coefficient. And if an object's moving really slow, like barely at all, then you also have a different power of v. It's just v to the first power, and you have a different, well, you might have the same drag coefficient, but you have a lower power of v. So this is moderate speed. So this is a few meters per second up to 100 or so meters per second, which is a pretty big range. Okay, see you in a little bit.